Hi, and welcome to Dear SQL DBA, a podcast for SQL Server database administrators and developers. I'm Kendra Little. Now, this week I'm going to change things up a little bit because I learned a bunch of cool stuff last week at the SQL Pass Summit in Seattle. And I wasn't able to actually record a podcast last week because, like happens a lot of times when you're at conferences, I had a cold, which was really hard on my voice, but I needed to also be able to present, so I had to really limit my talking when I was outside of the convention center and even sometimes in the convention center. So I have a lot of excitement bottled up from last week that I want to share with you. And this episode is not actually about a reader question. This episode is about one of the topics from last week that I have a ton of questions about. So this is the SQL DBA's questions about some new exciting new features that were talked about last week by the Microsoft SQL Server team, and that are some of which are actually available in preview right now in the cloud. And let's get into it. So today's question is, what is adaptive query processing in SQL Server? And this episode is going to involve a lot of speculation because I only know a little bit about this. We only have sort of the first information on this stuff in SQL Server, and I wanted to get my speculation recorded right now because next week I am fortunate enough to get to go to the Microsoft MVP Summit. And I may get to learn more about adaptive query processing. I may not. It may be on other topics. But when you're lucky enough to get to go to the MVP Summit, I mean, kind of the cool thing is you get to learn a lot of stuff that isn't announced yet, that isn't public yet. But the downside is that can kind of limit your speculation because, you know, when you have knowledge about something that's secret, you can't really openly speculate on it. It kind of spoils that. So just to be really clear, when I say I'm speculating today, this is nothing that I have secret information on. All that I'm talking about today is things that were publicly announced last week at Pass Summit, and then my guesses about how to interpret that or what it might mean in the future. So I'm not using secret information to speculate, and I wanted to get my speculation in before, I would love to learn more secret info, but it can spoil speculation. So I'll do my best to be really clear about what I'm guessing about, and that's most of what you're going to hear. So one of the interesting things from the start at the SQL Pass Summit last week, in the keynotes right away, there was a lot of emphasis given to prediction and talking about bringing intelligence deeper into SQL Server. What does that mean? Well, SQL Server 2016 features our services. And essentially, there's already been a lot of investment into bringing these predictive powers into SQL Server so that you can pump data into the engine. It can, our services can analyze a bunch of data, and then based on information that the designer, the user gives it, apply certain statistical models and teach it to predict things. Now, even my language describing that may have some errors in it because I'm not an R expert, but essentially taking patterns and using them to make predictions is a big new feature that we already have in 2016. In the keynote, there was emphasis placed on saying, okay, well, we're also going to make SQL Server smarter itself about making predictions and harness these features that we already have to improve SQL Server's performance, among sort of lots of other cool things like SQL Server on Linux and all sorts of cool stuff that was discussed. But it was really this idea of intelligence in the SQL Server that even in the first keynotes kind of caught my attention, and I was like, I wonder if I can learn more about that. Now, we are used to, when it comes to query optimization in SQL Server, what the SQL Server that we know and love optimizes a query before the query starts running. And we have the optimization phase starts and ends before query execution starts. So I send a query to the SQL server, and it has to like parse it and make sure that SQL makes sense and all that good stuff too. But optimization, it has to decide what's the best way to run this query given all the data structures I have. And it looks at what indexes are available. It uses statistics to help it figure out, well, about how many rows will come back from different indexes. And it has to figure out what are the right joins to use. Do I use one core or multiple cores? In places in the plan where I'm going to allocate memory, should I allocate a little bit? Should I allocate a lot? Like there's a lot of decisions to make, and it has to make them really fast because this is all done before it can ever start executing the query. So every millisecond or microsecond spent in optimization is time that, I've already submitted the query and I'm waiting, right? So it's got to be really fast. Now, we don't have a way right now in SQL Server where it'll start running the query and then be like, oh, I thought that was going to be really fast, but it's not. Or I thought that was going to be just a few rows coming out of that table for this query, but it was way more than I guessed. Right now, we don't have a way to do that in SQL Server. But some of us have wondered for a while if we might be able to get that because Oracle has a feature called adaptive query optimization. And I'm not an Oracle expert. I do not play an Oracle expert in any location, but I can read the Oracle release notes, and so can you. Oracle describes this in their documentation, and here's kind of the general lay of the land with adaptive query optimization. Once a query starts running, they can start the query with they call a default plan. And once it's going, it can look at, were my row estimates for certain parts of the query, were they way off? If it's finding that it was way off, it can change things once execution has started. It can change joins, it can change parallelism, and it can even create these little dynamic statistics if it figures out I need better estimates for this part of the plan. The documentation also says that it's smart enough that if it figures out, hey, for this query, I was way off base, it can use that for future executions of the query as well. And take, if it had to generate those extra statistics, if it had to generate extra information, it doesn't just throw that all out, but it may improve future executions of the query too. So I'm not talking about this Oracle feature just to say I'm not suggesting that SQL Server copies Oracle features like how they're implemented, but I do think that it's interesting to kind of look at what else is in the marketplace just in sort of thinking about what's possible and in thinking about what you're competing with, right? It's kind of, it's kind of interesting to know that as information. So I'm not saying that this is what SQL Server is doing. I'm saying this is just what it says Oracle does in the Oracle documentation. Now, so far, we've had some interesting stuff come out for SQL Server in terms of improving workloads in Azure SQL database. And I'm always like, do I have the current brand right? Because they keep rebranding things. I believe I just said that right. There's something in the cloud right now that we've had out actually for a little while, and it is still kind of new. I mean, it's not like old, right? But like it wasn't released this week, it passed. And they're currently calling it the SQL Database Advisor. I think this may not be its first name even in the cloud. Now, this is a little confusing. This is not the same thing as the Database Tuning Advisor that we've had in the SQL Server Box product for a long time. Like I'm kind of like my mom's Database Tuning Advisor. This is not just a new version of that. The SQL Database Advisor in Azure is something that And this is only in the hosted database, right? Like if you're running your own VM in the cloud, that's not this. This is when you're using database as a service, I like to call it, because that's just obvious, where they, manage your database for you. You can turn this on and say, hey, will you look at my workload? Will you let me know when you think I should drop an index because I have duplicates? Will you let me know when you think I should add an index? And this is different than ye old missing index suggestions too, because it's smart enough you can say, hey, will you go ahead and automatically create the indexes for me? You don't have to. You can just look at the recommendations yourself. But you have the option to say, hey, can you go ahead and automatically apply them for me? And then here's where things get kind of different. It'll look at, do they actually improve performance or not? And if it doesn't improve performance, it'll be like, okay, I need to revert that change automatically for you. So we've never had anything quite like that before. And because it's hosted and because it's the cloud, it's kind of interesting. Now, how well does that work in practice? I have some hesitations just because we do have a lot of locks that happen around doing things like creating and dropping indexes. Even if we create an index online, we're going to have some blocking at the end of that operation. And even when we drop indexes, we are modifying the schema of a table. So depending on the nature of your database and how large your data is, this could have impact on you, right? So that's why it's good that the automatic stuff is optional. I do have to say, I'm really interested in learning more about how this works in practice. I don't currently have an opinion on it. It's not something I've been using. We are getting to the point, I think, where there's enough going on with the cloud and enough people are moving into the cloud that this is something I really want to start learning about. So I'm very excited to learn about this. There's even more workload features they have that I haven't talked about, where they'll suggest where parameterization might be important to add to your queries and some other things in the SQL Database Advisor as well. It's not just indexes. But so kind of the big picture there. SQL Database Advisor, we're talking looking at your workload and looking at, do changes actually improve performance, kind of looking not just at one query execution, but looking at big picture and how can it change data structures to improve query performance. So going back to optimization, what got announced last week, at least I'm pretty sure it was announced last week, it's the first time I ever heard of it, is something called adaptive query processing for SQL Server. Now this is different than the SQL Database Advisor that I was just talking about. We have both of these features. And that's one of the things that I kind of wanted to be like, okay, these aren't the same thing, right? They're different. We can have both. Why can't we have both, right? Well, maybe we can have both. So adaptive query processing sounds a lot like that Oracle feature, right? Like the Oracle feature name is adaptive query optimization. So we've got one word different here. And I think it may be quite different, but there may be some similarities. Now, I learned about these in a session about what's new in Azure SQL Database. Lindsay Allen, who's a program manager on the SQL Server engineering team, and some other program managers gave this content-packed session on cool things they've been doing in Azure, including things like the Database Advisor. And they started talking about adaptive query processing. So this is about improving that optimization. And they said that it was really focusing, at least in the beginning, on three things. It's focusing on row estimates for what they're calling problematic subtrees in a plan. I heard the phrase problematic subtrees. It's working on adjusting memory grants for a query and for fixing join types. So, this query picked a nested loop plan. It would really do better with a hash join plan. Now, how does this work? I don't really know. I actually kind of heard and read two things that I'm not sure how they go together about how it works. So I'm really interested in learning more about which is right and what's really going on. Because part of what I heard was that this had to do with the predictive power of R. So in other words, we can collect data on how a bunch of queries have been running in SQL Server. And the new Query Store feature in 2016 collects execution plans and a bunch of runtime metrics for queries, right? So we have this great new way in SQL Server 2016 to collect a lot of info about how SQL Server optimized a query and then how execution came out. And we could feed that into our services and figure out what queries look like they could use some help. So let's think of, and we saw a cool video about, but it went kind of fast, and that's why I'm not super sure exactly how this works. But the video gave examples that were along the lines of just, so imagining this, let's say, and this is one that I've run into in the wild, so this is the example I'm coming up with. I had a customer situation where they had this really busy server, and they started having an issue with this one really frequent query. It could be run across lots of threads at the same time from different services. This query thought it needed a lot of memory. It didn't need nearly as much as it thought, so it would ask for a bunch of memory and then use a small amount of it when it got this problematic plan. And if this was run from a bunch of different services at the same time, all of those memory grant requests, the SQL Server would get low on what's called query workspace memory. Memory where you're going to do like sorts and joins in memory. And then we'd get this resource semaphore wait. New other queries would be like, I need a little bit of memory to do sorts and joins, and they'd have to wait. So we have this big backup on the SQL Server. And we had to fix this with like a plan guide. We had to get a little dirty. We had to get the duct tape out and say, we are going to not let you get this execution plan. And then we eventually got the query rewritten so it, we could take the duct tape off. But in this example, if we had something looking at the workload that could see this, it could see, hey, you always ask for a lot of memory, but you don't really need it. So I'm not going to actually give this query. You're a frequent flyer. I'm going to give you what you need, not necessarily what, you're optimized for outside of the context of this server. So a feature like this that looked at the workload could optimize that down. But that kind of sounds like the adaptive query processing feature would only help if you have a frequently run query. And there were a couple of things on the slides that made me think it might not just be that. So there was a phrase about deferring join choice. It said on a slide, and I typed this down, defer the join choice until after the first join input has been scanned. That kind of says that at least part of this optimization is dynamic and means that the optimization would stretch into query execution, right? If we're deferring join choice until after the query is running, that means that some part of the optimization sounds dynamic and would start after the query gets going. In other words, it doesn't sound to me like it's just sort of like run an analysis on the workload and then pin some plans. It sounds like some of this optimization, there's choices and some flexibility in there, which now that sounds really cool and interesting to me. There was also reference to, here's another sentence that I was like, ooh, and I typed it down from a slide, materialize estimates for problematic subtrees. So materializing estimates, okay, I think we're talking about statistics is my interpretation of that. And problematic subtrees sounds like either something that, and I don't know which, I'm totally guessing here. So maybe a subtree is problematic if maybe we're looking at it live and comparing the estimate to what's coming in. I don't know, but maybe it's something that when we looked at the historical workload, we noticed that was off. I'm not sure. I'm very interested, but I'm not sure. So at least from the slides, my belief is that some of this is going to change the nature of when optimization happens, at least if you're using this feature in SQL Server. Now, speculating more. If we are looking at a workload of queries and we're using, I'm guessing, Query Store to see what are the plans and how did performance go, wouldn't it need more information about why a query was slow? So the first thing that kind of comes to my mind, just kind of random guessing, is, well, if I was doing this and I was looking, at these queries, I would really want to know if a query, if it ran 5 minutes, was it waiting on locks for 4.9 minutes? Because if a query was slow because it couldn't get a lock resource, well, that doesn't mean it had a bad plan that needs changing. The wait stat information is so useful in SQL Server for knowing why a query was slow that I think really to make this work, it might mean that we could get wait statistic information recorded in Query Store in some format or another. I have no idea. I'm just kind of guessing because I would think that would be kind of vital information for it to figure out really well what queries it needed to improve. So we'll see. Kind of a big sort of hopeful guess, because I would love to have wait stat information as an option for Query Store to record. Is adaptive query processing cloud only? Well, I was in an Azure SQL database session when I learned about this, but I don't know. There were a lot of stuff discussed. Thinking it through, I didn't hear anything that seemed like it couldn't work in an on-premise or a manage yourself version of SQL Server. But a lot of times we are not going to get a clear answer on what is in the next shipped version of Run It Yourself SQL Server until we see the next Run It Yourself version of SQL Server. And even then, we don't always find out in the first previews what it's going to include. So I would wait for more information on where it might be available outside the cloud. It is in preview in the cloud right now. And you can go to, I have a URL. It's aka.ms/adaptive-QP preview. And if you go to littlekendra.com, hit up the blog post on this episode. This is episode 21. Let me make sure that it's really, Dear SQL DBA episode 21. And there's a link at the bottom of the post. So I would treat anything as speculation about like where and when you might be able to use this outside of that preview, unless it's a Microsoft program manager on the SQL team telling it to you. If you have more information about this feature, if you went to, there was a Chalk Talk at PASS that I wasn't able to attend, a Chalk Talk with the SQL team. So if you went to that session or have other information that you're free to share outside of NDA, I would love for you to comment on the post on littlekendra.com and share what you know, because I am really, really excited and intrigued by this new feature, and I'm really excited to see where query optimization goes in SQL Server. That's it for this week. Next week, I'm going to be at the MVP Summit. I will not be podcasting NDA stuff, so I will skip next week, and then when I'm home the following week, I will return with a new episode of Dear SQL DBA. Thanks, folks, and I'll see you soon.